Hello, everyone. My name is Al Patel, application engineer with LaMarche Manufacturing. Thanks. Thank you, everyone, for joining our last of three Charging Ahead Beyond Lead webinars. All three technologies have been widely used and have field-proven track records as battery storage solutions. The lead acid and NiCad chemistries has been used for many years. However, today we will become more familiar with a new emerging technology with many benefits and advantages. Today we will learn about LaMarche's hybrid capacitor module. During the webinar, we will discuss the technology, benefits, and applications, along with what LaMarche can offer as a charging solution. I hope today's webinar will provide a more in-depth knowledge of these emerging technological advances in battery backup solutions. LaMarche has been designing and manufacturing power conversion products for over 75 years. During this time, our engineers have participated in different working groups and committees to stay on top of the new technologies. This allows us to provide the optimal backup systems and charging solutions for different types of batteries. Today's agenda, we'll talk about what an HCAP is, which is the hybrid capacitor module. We'll talk about the differences between the HCAP and lead acid type batteries. Talk about the benefits the HCAPs provide in storage solutions. Talk about the applications where HCAPs are used, such as engine starting. That will be our primary focus in this webinar. And then we'll talk about the engine starting chargers that are available, manufactured by LaMarche, to charge the hybrid capacitor module, both the LMSC Pro along with the USC. And then we'll wrap it up with a success story that we've had when we launched the product. Before I begin in the hybrid capacitor module, here are some pain points that customers have faced when starting their generators. The number one reason, 80% start failures are battery related. A dead battery can cause that. Improper charging, whether it's the wrong charging voltage or the charger itself. Cable corrosion or a trip breaker that's providing power to the starting system. Number two, conforming to the 10-second rule per NFPA requirements. NFPA requires that all generators ramp up to speed and provide the proper output within a 10-second of a power failure. Bigger buildings, failures to start is more costly, meaning hospitals where lives are at stake, hotels, server farms, data centers, and batteries themselves. They're very costly and high to maintain. And the unknown reasons where a battery can fail randomly without any notice, because a lot of people don't have a maintenance program in place. All these items can result in extreme expenses, loss of productivity, loss of revenue, and compliance issues. And that's the reason why we're introducing the hybrid capacitor hybrid supercapacitor. As you can see, it looks just like a normal battery, but within the battery, it's got capacitors. And with the capacitor, there's a mixture, another component, which is lithium. The capacitor is a symmetric electrostatic source of energy, and the lithium provides a long duration part of that. Combine both of them, and you get the best of both worlds. Lots of power, along with a long duration backup. Here's a graph that shows you the basics of energy and how batteries provide a lot of energy, and where you have EDLCs, which is basic capacitors, supercapacitors that is, and they provide a lot of power. So batteries will provide a lot of energy, but they take longer to recharge. On the other hand, capacitors provide a lot of energy and take a lot less to charge up. So a combination of that would be the asymmetric hybrid lithium capacitor. You get cycle life with the supercapacitors, the lithium ion hybrid capacitor. You get a lot less with batteries. Some differences between the hybrid capacitor and batteries themselves. Hybrid capacitors are rated in amps, while the lead acid batteries that are used in the engine starting market are rated in cold cranking amps. They both follow a common group size. However, with the lead acid, there really isn't an independent sizing guidance on how to really size lead acid batteries for engine starting applications. For the hybrid capacitor, Lamarche has developed a calculator to go and size it based on certain parameters on your generator. The design life on the hybrid capacitor is well over 15 plus years, while the lead acid type batteries, they're around 2 to 3 years, maybe a little bit longer, but NFPA recommends that you replace your genset batteries every 2 to 3 years. The HCAPs provide a wide range of temperature, while lead acids, like the optimal temperature range, is 77 degrees F. With the HCAPs, there is no maintenance required. There is no electrolyte. With the lead acid, there is sulfuric acid along with the electrolyte. HCAPs that are a lot less weight. The footprint is small. And the other benefit, it can recharge less than 2 hours. While the lead acid, typical recharge times are 8 to 24 hours, depending on the application. So as you can see, there's a lot of benefits going with Lamarche HCAP versus typical lead acid 8D or 4D type batteries for genset applications. Here's the different models that we offer. We offer both 12-volt nominal modules along with the 24-volt modules. As I mentioned, they are rated in amp hour ratings. We offer both 10 and 25 amp hour ratings for the long duration backup, and the high current power ratings that are required for engine starting applications. The other nice thing is this self-discharge on these are about 180 days. So you can leave them in storage and still be at its highest performance even 180 days later. And the wider temperature range that I mentioned earlier, which is minus 40 degrees C to plus 65 degrees C. Along with the weight. As you can see, a 28-volt module weighs only 26 pounds versus a 4D or an 8D battery weighing around 80 to 100 pounds. So where are these HCAPs used? Again, they're used in engine starting applications. Here's a typical engine starting system, kind of a layout. Concentrate both on the charger and batteries. The batteries provide power to the starting system along with the HMI. The starter is located on the engine typically, which provides the high energy, the high power that the HCAPs can provide, along with the HMI, the continuous load. In this particular case, we are showing batteries there, but we're going to see how that gets replaced with our HCAP modules. Here's the electrical diagram, a typical layout for an engine. Again, you're supporting your HMI there on the right under normal operation. And then when the engine starts, you're providing power to the starters to crank the engine itself. There's also a generator, an alternator on board that would charge the batteries when the generator is on. But when the generator is not on, you need to make sure your batteries are at a high state of charge, and that's where our charger would come in, which is a USC or the LMSC Pro, providing charging to the batteries or HCAPs. Here's a scope shot basically of a 3 cycle start per NFPA. Generators start within 3 crank cycles, duration of 15 seconds. Now, as you'll see during the starting, the starter can draw 1400 amps, which is called the breakaway current. Once the breakaway current and the engine has started cranking, the rollover current could be as much as 470 amps. As you can see, that's a lot of amps that the battery needs to support. In this case, that's one of the reasons why the HCAP is the preferred source, because that provides a lot of current, a lot of power for a short duration period. With the added lithium component, it provides a long duration operation. The other thing is that you must maintain a voltage to make sure all your control systems and electronics are affected. And here are some of the items that can get affected with low voltage ratings on the battery. First of all, your cutoff point. As you crank the engine, you want to make sure the voltage is maintained so it doesn't fall below the cutoff point. The ECM, the electronic control modules that are on board, along with possible switchgear that can get affected. Typically, as I mentioned earlier, there is no guidance on sizing engine starting applications using lead acid batteries. Lead acid batteries are used for long duration, and here's a typical IEEE 946 calculations that are used. The way they size lead acid batteries for generators is basically they do it the old school method. And what they do is they look at the datasheet generator and recommended battery during cold cranking amps are required. They take that number and they basically just double the number of batteries. Again, you'll get your redundancy and you'll get more than enough current to go ahead and crank the engine. On the other hand, our HCAPs, we take a little bit more information about the generator. And we want to make sure that it will start within the time required by NFPA 110. So what we require to go and size this is the engine displacement, the system voltage. In this case, we got a 50.4 liter engine with a 24 volt nominal rating, and then a low voltage cutoff. Make sure all your controls are still operated during the crank cycle, which typically would be about 17 or 18 volts. Number of starters that you may have on board, and the oil viscosity. Now, this is really important because all engines, as you know, when you're in a 0 degree environment and trying to start an engine on a car, it takes a little bit longer because the engine is much colder because of the oil. And oil is friction, and there's a delayed start. The time of duration for their cranking, which is typically 15 seconds per NFPA 110, and you want to make sure you maintain at least 3 cranking cycles. In this particular case, we're using 50 degrees Fahrenheit because it's equipped with an engine generator heater. And then which module you're going to use. We have 2 different versions, the 600 and 900. And the maximum current, there's an aging factor, and then also the battery temperature factor. In this case, it'd be 1. There really isn't any because it's got a wide range of operating temperature from -40 plus 65. And then also the mins and max charging voltages. In this case, this particular requirement calls out for only 2 HCAP modules. Again, 2 HCAP modules weighing 50 pounds versus having 2 8D batteries that are weighing 170 to 200 pounds. Much smaller footprint, a lot more less weight. No maintenance to worry about. So we'll move into what charges these hybrid capacitor modules. LaMarche offers 2 different chargers that will do that, and they got their own profiles to go ahead and charge the HCAPs. These can also charge nickel cadmium and lead acid. The LMC Pro Smart Charger is designed to recharge and extend battery life while utilizing a multi-stage charging. The charger is completely automatic, it's lightweight, and has a universal input range. We offer both 12 and 24 volt modules and is convectionally cooled, no fans. Even though this is a switch mode product, most switch mode product, microprocessor controlled, there are some that have a fan on that. Ours is convection cooled. Most generators are installed outdoors and have a wide temperature range. The multi-stage charging system that we have on the LMC Pro is 4 stages: bulk, absorption, float, and equalize. The equalize is mainly for the lead acid or NiCad. The HCAP does not require an equalization. The LMC Pro also meets CEC efficiency requirements and is IP32 rated. Also provides reverse polarity protection, has built-in monitoring system to monitor high voltage, short circuits. Also has input and output transient voltage protection, along with over temperature derating. It has 2 conveniently located, 3 LED located right in front of the unit for AC on indication, status charging stage, and also a fault if there's a charger fault. Here in the lower right hand corner is basically a setup for easy accessible dip switches where you go ahead and configure the charger to charge lead acid, NiCad, or hybrid capacitor modules. The other charger that can be used to charge the hybrid capacitor modules is our USC. The USC is also a microprocessor high frequency charger. It can also charge lead acid, NiCad, or lithium ion hybrid supercapacitors. This particular unit is fan cooled, has temperature compensation, and can be mounted on a wall. It complies with UL 1236 and UL CUL. USC complies with NFPA 110, which requires you to have 4 alarm contacts, low voltage, high voltage, low current, and AC fail. Again, why the USC versus other traditional chargers? It provides a wide temperature range from -40 to 65 degrees C, has a 3-stage deep discharge battery algorithm to protect batteries and charger, and it's also adjustable to charge supercapacitors or lithium ion hybrid capacitors, along with lithium ion, lead acid and nickel cadmium cells. And in today's internet age, everyone wants all the information at their fingertips. We can also provide Modbus communication, RTU, or optional TCP. We have also added on SAE J1939 communication, which is used in a lot of genset applications. Here's the lithium ion profile that's used with the USC. Stage 1 basically is the bulk charge, followed by the absorption. And then stage 3 and 4 are basically the topping off charges. Now, Lamarche provides a 5-year warranty on the HCAPs if you use a Lamarche charger, the USC or the LMSC Pro. It has been tested with these proprietary profiles, charging profiles, and that's why we have extended the warranty out to 5 years. Modbus and J1939 provides communication status monitoring for DC output voltage, DC output current, all alarms that may be present, and the charger mode. You can also set remotely the charge mode, load equalize, or even adjust the alarms. And that's why the LMSC Pro and the USC is a preferred charging source solution for the HCAPs, along with NiCad and lead acids also. The LMSC Pro is a cost-effective solution. On the USC provides a competitive voltage and amp sizes, meaning larger sizes, such as 40 amps or even 65 amps. The LMSC Pro is designed for OEM opportunities that go on large volume generator sets. Both units provide 12 or 24 volt DC output ratings and both comply with UL standards. Now we'll look at other applications that our HCAPs can be used in. Uh, Perfect and ideal for portable generator sets where you're going to have the HCAP stored away inside the generator for some period of time without being charged. So it's a great option because of the long discharge rate on HCAPs. Also larger generator sets. And we'll talk about that a little bit later at which was one of our success stories, where they had portable generators and instead of having the lead acid batteries stored outdoors in 0 degree temperatures, they preferred to go with the HCAPs, which provided a wide range of temperature. And here's a picture of one of our engineers, Rich Hutchins, doing some field testing on a 50-liter generator. As you can see, there's not much room there, and trying to move around 8D batteries inside this particular trailer is a little difficult. And that's why the small compact size of the HCAP is the perfect solution. Also larger generator sets. As we mentioned, many critical locations where batteries may not be the first maintenance item on their list. Uh, with the maintenance-free HCAPs and long-term operation, it would be the ideal source. Traditional NiCads and lead acids can take up a lot of room, as I mentioned earlier. And that's where an HCAP would be the perfect source also. We'll talk about some other complementary products. HCAPs currently are not recognized by NFPA 110. And for that, we can provide an ARBS solution where you can go ahead and install your lead acid or NiCad batteries in parallel with the HCAPs. And basically, ARBS is the automatic redundant battery selector and would select between source A or source B to provide the proper current to the generator starting. And here's a diagram of the NFPA compliant system where one of the sources you have the HCAP. On the other side, you have your traditional NiCad or lead acid batteries that NFPA mentions. We are currently working with NFPA to get this the HCAP as an approved battery storage system. And the nice thing about this solution, the HCAP provides the short duration current that an engine may require, while the batteries have the long duration. This will also extend your battery life on the lead acid and NiCad because most of the short-term current power will come from the HCAPs. Now I just want to go over a case study that we had done about a year and a half, 2 years ago. This particular customer is a utility customer that had over 55 plus generators. Their concern was safety. Basically, the chemicals that are in lead acid and NiCad batteries being a health hazard, along with also disposing these batteries. The weight. What they wanted to do is instead of call their local dealer or that does the servicing on the generators, they wanted their own technicians to go and do servicing on the generators. And lifting 80 or 100-pound batteries was a big concern. They wanted to reduce the routine maintenance. Now that their own technicians were doing it, they wanted to make sure the batteries they select are long-term and do not require as much maintenance as lead acid might. They wanted to make sure the batteries have an extended life versus a typical lead acid or NiCad battery system. And the final reason was minimize cost impact. One would switch over and also routine maintenance. Their system consisted of 50-liter, 1.5 megawatt generator where they had dual starters. And that's where they had 4 sets of batteries, HDs, and they selected to go with one HCAP, two HCAPs on each starter versus 4 batteries. Here was their initial setup, and as you can see, they replaced them with HCAP 1 and HCAP 2 to start both starters. So at the end, the customer saved or will be saving over 50% over a 10-year period. Again, total cost of ownership was one of their big objectives there. They wanted to make sure they reduce cost over a 10-year period. So instead of replacing batteries every 2 to 3 years and having their generator supplier dealer do this servicing, they were able to go ahead and start doing their own servicing, basically, just monitor checking the connections on the HCAP. There is no electrolyte checking or any of that, no load testing required. And it's 10% of the weight. Again, they wanted to make sure they didn't create any health hazards by lifting the lead acid, sulfuric, or electrolyte type batteries. Also took up half the space, and there was no maintenance required. That kind of concludes today's presentation. Open it up to everyone for any questions that they may have. So I got one question here. What are the charging voltages? The, the 24-volt module, the recommended charging voltage is 28 volts. On the 12-volt module, it'd be 14 volts. Any other questions? Well, I want to thank everyone for joining today. Oh, here's one question. What is the warranty on HCAPs without buying the Lamarche charger? The warranty would be 1 year without buying the Lamarche charger. Otherwise, if a Lamarche charger is used, you'll get a full 5-year warranty. Another question, have we deployed any of these systems to Canada? Real close to Canada, up in Wisconsin. Uh, so the systems that we've already deployed and the success story that I mentioned is in the Wisconsin area. So they are exposed to negative temperatures, just like Canada. Any other questions? Another question popped up. Are these considered hazardous material where it requires an MSDS sheet? These particular modules cannot be shipped on commuter passenger air freight. They get disposed just like normal electronics do. They don't need to be specially recycled. So we recommend you just contact your local authorities on disposing electronics. Okay, again, thanks everyone for joining. today and have a good afternoon. And if you do have any questions, please reach out to us at sales@lamarchemfg.com. Thank you, everyone.